Lesson 19.2, Task 3, Quadratic Functions in Standard Form. All right, graph a quadratic function given in standard form. To graph a quadratic function given in standard form, it is helpful to rewrite the function in vertex form. All right, arches have been used in the construction of buildings and bridges for centuries. Suppose the large arch for the structure shown is approximated by the function y equals negative 0.1x squared plus 2.2x, where x is the distance in feet along the ground from the left end of the arch to the right, and the y is the height in feet. Draw the parabola that models the shape of the arch by graphing the function. All right, so you can see here is the parabola given. You can see the parabola here. Even has a shadow that has one as well. And it says you can approximate the shape of some using a parabola. So rewrite the equation in vertex form by completing the square. All right, so the function above was given. That's this right here. And so what we're going to do is first factor out the negative 0.1, factor out your a value so that this is just x squared. But when you do that, you have to factor that out of both terms that have a variable. So your quadratic and your linear term. And when you do that, the 2.2x becomes 22. So if you want to, you can just divide that out and see how that works. All right, so negative 0.1 equals this. So where did this number come from? We completed the square. So you take 22, you half it, which is 11. 11 squared is 121. So you're also going to subtract that, so you're going to add that number and subtract that, but to subtract it, it's going to be the opposite of a times that number. So that's where that comes from, and 0.1 times 121 is just a 12.1. So this is standard form. There's no constant term, so it's just an a and a b, and then you rewrite that in vertex form, and remember this is your h and this is your k, so it's x minus h, so h is just 11, and k is 12.1. All right, so it says choose the features that can be identified with no additional calculation when the function is written in vertex form. All right, so we can identify the vertex, h and k, and the axis of symmetry is whatever the x value of the vertex is. So both of those can be determined quickly and easily when it's in vertex form. Identify the vertex, the axis of symmetry, and 2 points where the graph intersects the x-axis. So the vertex is 11 and 12.1, and the axis of symmetry is x equals 11. So the axis of symmetry always goes through the x of the vertex. The given equation has no constant term, so the point 0, 0 is on the graph. Another point on the graph is 22, 0. All right, so if this is 11 and we know that 0, 0 is on the graph, we know that that's 11 points to the left. And if we add 11 points to the right, that's where the 22, 0 comes from. So remember in the last task, it was talking about subtract b and add b, and that's really just an arbitrary point. So that's just going 11 units to the left and 11 units to the right, so that when we sketch the parabola, it is symmetric about the axis of symmetry. All right, complete the statements to explain how you know 22 is on, or 22, 0 is on the graph. Okay, so the point 0, 0 is 11 units away from the axis of symmetry. The point with the same y value will be located 11 units away from the axis of symmetry on the opposite side. So 22, 0 by definition of symmetry. So again, you're just adding and subtracting the same number to the axis of symmetry to get 2 additional points on each side of the vertex. All right, sketch the graph. The coordinates of the point 5 and 8.5 satisfy the equation. By symmetry, the points 17 and 8.5 is also on the graph. Plot points at, so there's 5 points here. You can see there's 5 dots that identify with these 5 points here. So use these points and symmetry to sketch a parabola that models the arch. So once you have the points, you just easily sketch the curve. And then it says, why is the axis of symmetry helpful when sketching the graph? Well, if you know you have the vertex, the axis of symmetry goes through that, and each of these points is just a reflection across the axis of symmetry. So it just makes it a little easier to graph those points. So actually, if you find points on one side, you can just reflect those over, and you don't necessarily have to work those out. All right, that's all for task 3. If you have any questions, let me know. Lesson 19.2, task 4. Analyze real-world quadratic functions in standard form. Recall that the projectile motion model describes the height of a projectile over time. The projectile's height is determined by this function. All right, so we've seen this in previous lessons since we've started working with quadratics. So h of t equals negative 16t squared plus v sub o t plus h sub o. All right, or sub 0 if you want to call it 0. Where h of t is height, so h of t right here we're solving for height, and t is in seconds, so t represents your time in seconds. V sub o is the initial velocity in feet per second. Initial means your starting point, and h sub o is the initial height in feet. So this would be your initial height where you started. All right, so it says Olivia is throwing a baseball straight up into the air at a velocity of 32 feet per second. What is the maximum height that the baseball reaches and the time at which this height is reached? All right, so she's starting at an initial height of 5 feet, and it says it has a velocity of 32 feet per second. So we can use that to plug it into the equation. So you can see since the initial velocity is 32 feet per second and the initial height is 5 feet, the height of the baseball above the ground can be modeled by h of t equals negative 16t squared plus, substitute 32 in for here, so plus 32t plus substitute your initial height in here, which would be plus 5, where t is the time in seconds since Olivia released the baseball. The vertex of the graph of a quadratic function with a negative leading coefficient gives the function's maximum value. So the vertex of the graph of h gives the maximum height reached by the ball. So rewrite the function in vertex form. All right, so what we did was take and plug in our values. Now we're going to rewrite this, so they're going to take negative 16 and factor it out. That's because to rewrite it, we need to do completing the square. So the first thing you need to do is get rid of your a term by factoring it out. So negative 16, factor that out of your quadratic and your linear term. So we've got negative 16 times t squared minus 2t. Negative 16 times negative 2 is 32. So they just rewrote that in factored form. Now, we're going to take this middle term, we're going to half it and square it. If you half negative 2, get negative 1. Negative 1 squared is 1. So we're going to add 1, but that 1 is like a negative 16 because you've got negative 16 times 1. So we have to add 16 times 1 in order to offset that. Remember, completing the square. Now that we're manipulating the equation and doing the same thing on both sides in order to get rid of that. So if we subtract 16, we have to add 16 so that we're not changing the equation, just changing the form and the way it looks. All right, now that we made this a perfect square, by completing the square, we're going to rewrite in factored form. So this trinomial becomes t minus 1 quantity squared. You bring down your a, and now we can do 5 plus 16, which is 21. So this is standard form. We rewrote it in vertex form. So it says complete the statement explaining the first step of the process. The first step was factoring out the negative 16. So to complete the square, the coefficient of t squared should be a 1, not 0. Remember, if t squared is 0, that means there's no quadratic term. It would not be a quadratic equation. So it has to be 1. 1t squared. T squared is just a perfect square. And then that way we can use that to complete the square. This is the reason that negative 16 is factored out. Choose the words and numbers to complete the statements explaining the steps shown. All right, so we've got negative 16 times t squared minus 2t plus 5. All right, so right here where they added 1, because this is in parentheses, that's negative 16 times 1. That's just that placeholder there. So because that's negative 16, again, we had to add 16 times 1 here. So it says, when completing the square, 1 was added inside the parentheses because the factor outside the parentheses, this has a net effect of subtracting 16. Again, negative 16 times 1 is like subtracting 16. To maintain equality, you need to add 16 to the end of the expression. And again, that's just because we have an equation and you want to maintain that equality. Okay? So this form of the function reveals the vertex to be the point 1, 21. All right, right here, opposite h plus k. So h and k, so that's where the 1 and the 21, that is your vertex. The baseball's maximum height is 21 feet. That height reached, so you reach that height in 1 second. All right, so it says the average rate of change in h of t on the interval 0 to 0.5 is what? All right, so t, we're only looking on the interval of t. So remember the average rate of change. All right, so we got the average rate of change is going to be y2 minus y1 over x2 minus x1. All right, so if we're given the interval 0 to 0.5, we're given our x values. So the first thing we have to do is 0 and 0.5. So the first thing we have to do is find our y values. Okay, so how are we going to do that? We're going to look at the equation and simply substitute those numbers in. So let's go back and find our equation. All right, so we've got, I'm just going to use y because it's a little shorter, but it's same as h of t. So y equals negative 16 t squared plus 32t plus 5. Now, you can use standard form or vertex form when finding the average rate of change. You're going to get the same answer regardless, but I'm going to use standard form. Because for me it's a little bit easier. You're just going to type it in your calculator and go with it. All right, so if I plug 0 in, 0 times anything is 0, so 0, 0 plus 5. So if we substitute 0 in, we get 5 for this one. That's our y value when we plug in 0. And then we're going to plug in 0.5. So just take your calculator and quickly do this. So if we hit clear, and then I'm going to do negative 16 times, and then t, we're going to plug in 0.5. So 0.5 squared, and then plus 32 times, and again, t is 0.5 in this case, and then plus 5. So it's got plus 5 here on the end. So we're going to hit enter, and that's going to give us 17. All right, so that helps us find our second ordered pair. So again, they're giving us an interval of t. T, remember, is your time. This is like your x values. So we have to find the h of t, or the y values. So once you have your ordered pairs, remember, your slope or your average rate of change is your difference in y's over your difference in x's. So we're going to do 17 minus 5 over 0.5 minus 0. 17 minus 5 is 12. 12 over 0.5. And I believe that's going to be 24. Let's check that quickly. So if we've got 12 divided by 0.5, that equals 24. All right, so that equals 24. All right, so the first average rate of change here that we found is going to be 24. It says the average rated change of h of t on the interval 0.5 to 1. So now we're going to look at 0.5 to 1.